Hello everybody. Just wanted to take a moment to go over the assignment from earlier. The first part of the assignment, all you see here is just some background information, a video, the notes we took the other day in class, and the speed equals distance divided by time equation. The next part of the assignment was a question about Judy. She went to the train station to pick up a friend who was coming for a visit. And she drove to the train station. You can see that in the first segment of the graph. Here's her driving. She waited for her friend to come out to the car. That's this section right here. And she drove home. That's the third section of the graph right there. So let's look at question A. What is the distance from Judy's home to the train station? So home, remember, is always 0. The train station where she waited is here. So if we look over, 40 kilometers away, so we know that Judy is 40 kilometers from the train station. Once arriving at the train station, she sits still for a while. She is stationary, waiting for her friend. She begins to wait at 4 o'clock. Her friend comes out between 6 and 8, which is 7. So between 4 and 7, she's waiting. And that gives us 3 hours. She waited for 3 hours for her friend to come out. When her friend does come out of the train station, the two ride back home, and it says calculate for part C Judy's average speed on her way home. So she traveled a total distance of 40 kilometers, and she did that between 7 and 9. So 40 kilometers divided by 2 hours is going to give us 20 kilometers per hour. Question number 2, Robert left school at 3:30. He's walking home. On the way home, he stops. He talks to a friend. His sister Amanda left school at the same time, 3:45, and she rides her bike. She's cycling home using the same route. So here's Robert. We can see that he's a bit slower, and also includes the stop that he had with his friend. So it says find the distance Robert walked during the first 10 minutes of his journey. So it starts at 3:30. At 3:40, if we go up, we could see he is at the 1 kilometer mark. So he traveled 1 kilometer. B, find the total time that Robert stopped to talk to his friend. So that's the distance here of our flat section. So he started chatting at about 3:45, and about 3:50 he's on his way again. So about a 5-minute conversation. Where did the two meet up? This should say Amanda, I'm sorry. Where did Amanda cycle past him? Right here, their lines cross, same spot, same time. So they must have encountered each other here. And that, if we kind of scroll over a little bit, is the 2 kilometer mark. Question 3, Pete visits his friend and then returns home. The travel graph shows some information about Pete's journey. So the first part here, A, write down the time that Pete started his journey. So you have to kind of figure out what each of these little boxes represent. And if I look at this, it's 60 minutes, and there's 4 boxes. So 60 divided by 4 tells me that each one of these must equal 15 minutes. So 1 o'clock, 1:15, 1:30, 1:45, 2. So right at the middle there, he started his journey at 1:30. And then it says at 2:30, Pete stops for a rest. So that's the flat section here. Find his distance from home when he stopped for this rest. So the distance from home, we just kind of move our cursor over. We can see it's 10 kilometers. And how many minutes did he stop? Well, he started to his rest at 2:30, but then was back on his way at 3 o'clock. So 30-minute break. Question C, Pete stayed with his friend for an hour. That's shown up here by that second stop. And then he went home. So what was the total distance that he traveled on this journey? Well, he went 18 kilometers. I can see that by looking over here on the way there. And then he went 18 kilometers on his way back. So we have 18 times 2, which is a total trip of 36 kilometers. Well, I hope that helps. If you had any questions about any of those distance time graphs, if you're still having some questions, feel free to email me. I hope everybody's doing good and staying healthy.